start off where I left off last time because we ran out of time, and I was letting you guys get out of here earlier. Um, we have a rigid body over in the lab that has been made already, and Yao was over there ready to activate it. We did camera moves last week, almost, but thank you for being ready. So we did camera moves last week, and we did this. We did the sequencer stuff. You guys saw that there was a lot of potential there for moving objects, animating objects, and doing camera stuff. I'm going to get into sequencer just a second again to show you how to export movies or image sequences out of it, because obviously that's going to be super important coming out soon. But also, you can record these things in using also rigid bodies. We have a tripod and an actual wheels for the tripod in there, so you can actually just do these moves in motion capture and do your camera work there. You could do it handheld, and you could do it on the tracks, and that could also be a fun, quick way to get some recordings for your trailer. So this is going to be the camera, and we've seen the camera thing before. We talked about it, very briefly, like somebody being in virtual reality, being a performer, and as they move around, you get to see what they're seeing projected around in the environment and all that kind of stuff. And we're just going to do that really quickly. This is the mocap computer with the rigid body. We've done this in the labs at the very beginning of the class. And then we are going to start from scratch, kind of. I'm going to throw in a camera. And I've already installed the OptiTrack plugin. So if I put in, so on this camera, I'm going to add a component to it. And we have OptiTrack, rigid body. This is a good refresher for everyone. And we only have one rigid body, and I know it's number 1. It's the first one. So our tracking ID is number 1. And all we have to do is add in the orientation, the origin from the OptiTrack to tell it where 0, 0 is in our world. There we go. And then let's see if this, and then go to the camera, and there's a property down here. We need to tell it it's player 0, and hopefully this will just work. So is it working?
Do you want me to move it?
1 second. I think she might be moving it. Rigid body one. Oh, I didn't do half the stuff I was supposed to do. 1 second, guys. Let's actually put in the values for the client and the server. So the server is 192.168.1.2, which is the mocap computer, and the Unreal computer is 192.168.1.5, and then multicast is fine. So just play in the viewport. We have a camera. So this is how you can do live camera work. Like you can get, I'll bring in a shoulder mount, and it's really great to get like some cool handheld stuff. Yeah.
Yeah. So I have a question. So currently we use this camera to record work, right?
Yeah.
But for the default, the gameplay here is a default camera. So where we can just to determine which one will be the first one to take usage of.
Correct. Yeah.
So which one will be? How can we determine which one?
Oh, which one's the camera that's being? So I don't know if you saw that, but this is the one camera right here, and I made it player 0 down here.
Yeah, so you would essentially make a multiplayer game,
Mm-hmm.
and then one.
So essentially, eventually, it actually is currently in a multiplayer mode, and we just determine which one will be the priority by its order.
Yeah. So just to go further and to kind of tie it all in with what we did last week with other cameras, I should probably use a mouse for this camera. So we have another camera that we can put at 90 degrees facing the other way, and then another camera that's facing negative 90 degrees, right? We take these other two cameras, and then we just drag it up to the first camera, and now they're parented to that first camera. We still have to go in and identify which player these are going to be. So where it says auto activate for player 1 and auto activate for player 2. Go into these play settings, and I'm going to say there's going to be 3 players, and then I'm going to go to play in a new editor window. So now we have 3 cameras that are all oriented to a dolly, a movement, a totem, or whatever. Now you have the perspective of these different objects. It'd be better maybe if there's something to look at besides a floor. This is a very rough prototype of my idea. So that's basically like the idea. I just wanted to show you the multiple cameras with the tracking, bring it back into that room. This is a motion capture class, so that gets us going with that. And then that's pretty much it. All I want to show you. I'll just save that for myself using the Mac Duo thing. All right, and then we're done with that computer. And if I open up last week's example that had the camera moves that we did, remember we did a crane and we did a dolly. We'll go into sequencer and I'll just show you. I mean, it's really simple. It's just how to export those video frames so you can play around with it. And you know, this is not limited to. This renders out very quickly, and it's good. We're done. Thanks. This renders out very quickly, and it's a great way of if you're good at making things look good on Unreal. This can do extremely large things, like one group last year for big screens did their entire big screens, which is thousands and thousands of pixels wide, and it rendered out super quick because this is still designed for real time. So let's go into the level with the move. That was not it. It was this one.
Will you use Unreal for these things?
CC and Joanna used Unreal for big screens last year.
But it wasn't real time, but it was like
No, it was pre-rendered, but it rendered out super quick. Like whereas the people who've done like Cinema 4D or whatever have spent like render farms, and this is designed to be real-time engine, and you can you're limited for live video at 4K for going out of like the card that's on the big computer over there, but you can render out to your hard drive at unlimited things. It just takes longer. Sometimes it can take maybe 30 seconds or something, but you can do really large renders.
actually render out the right resolution.
Yep. Yeah. And so if I find where that cinematic was it this one? This is where my moves are. And so it's just right here. You render. I should have added this, but just say video sequence, PNG, JPEG, BMP, and then there's also custom render passes where you can render out like depth imaging and other kind of stuff if you want to start kind of compositing things later on. And then you have a resolution. You could choose custom, but it has some presets, and then it just renders out to a folder where you designate it. Super simple. There it is. It all comes out of what your moves are. I don't know if you remember the 8-bit example where they had some camera moves and they also had the balls moving. That wasn't any motion capture. That was just animating a thing here, a thing there, and a camera here, and a camera there, and it looks really great. And so this is a great way of getting some quick renders of stuff pretty good. Okay. So I'll go into I'm going to go into some more connectivity and some more camera work. But we're going to switch over to a good friend of mine right now, which is we're going to switch over to Max, and I'm going to show MIDI. So oftentimes, especially when you get into making like VR and stuff like that, it's easier to control things and with sliders, knobs, and buttons instead of just this. So connecting these kind of things, it helps you, like for instance, putting on VR, you can actually control items when you're with feeling it in and really dialing in values. Yeah.
So you will use a Maxim to get connection with Unreal, rather than you will use a MIDI controller inside of Unreal.
Yeah, I'm gonna show this way because it's gonna tie in with the Touch OSC that we're gonna be doing. So it's you can do whatever way you want to, for sure. But there is MIDI control in Unreal. So I'm just gonna connect it because this is a quick, easy way of visually doing it. Because you can also adjust max real time. You don't have to recompile. So it's there's one object, and I'll make this a bigger screen for everyone. This is a Korg Nano Control. They have them for keyboards and drum pads. This one just happens to be sliders and knobs, and this one's been used extensively. And there's an object. So just a little Max primer. When you have Max 7, all the things you could do are just, these are all the objects you can do with Max. And we have an object. We're going to do an object today. Drag that off, and this is an empty object. And for MIDI in, it's called Control N, CTLIN, and it like auto fills it for me. And then I have some MIDI values coming in. And you see there's inlets and outlets, and I want to get stuff out of the outlet. This is very much like Unreal, but Unreal's left to right, and this is top to bottom. There's another object right here called a message. This is a way of tapping in and seeing some of our data. I'm also going to, let's make this a little bigger. I'm also going to show you that I can mouse over these values, these outlets, and it says this is a controller value, this is a controller number, and this is a kind of this is the MIDI channel. There's like a universe with channels inside and values on that channel. And you can distinguish all these different knobs and buttons by finding out which channel they're coming from, and then using the values and scaling them how you want to go into Max. So we're going to peek in and see what these numbers are. So I'm just going to be dumping out data into these things. And I'm just going to slide. So now we see we're in the, if we read it from right to left, we're in the world or the universe of 1, which is every button on this thing is a 1. It's on channel 7, and there's a value from 0 to 127. This is channel 6 next to it. And 5, which is ripped off, and 4 is ripped off, and there we go to 3, which is very, very crusty. Anyway, you guys want to borrow this from me anytime you want. So how do we get these numbers? How do we distinguish between these items? I want to play around with 7, which had pretty good action. So I'm going to add in an argument. I'm going to add in a value of 7, and we saw one of these outlets disappeared. We don't need to read it anymore because we've hard-coded this to be a 7. Now we have that value, but if I go to 6, there's nothing, right? So now I've correctly mapped in a from control 7 to here. And if I want to, I'm highlighting this and using Alt and dragging. If I want to have 6, 6 goes there, 7 goes there. This is live show control. This can get you anywhere, right? So we want to send this to Unreal to control. Let's do a camera, just so we have another way of doing cameras. We now have like 3 ways of doing cameras in Unreal. So I am going to send this on OSC. And then I'm going to show you guys again, because I had a bunch of questions from a lot of people on how to do to get the OSC plugin working. We're going to do that again. One of the important things about values is being able to massage them and scale them. And one of the things that's great about having Max here is that there's a scale object that we can change in real time. If we actually press the right buttons, there's ALE. And just like you guys are used to in other languages and other platforms, we can do from 1 or from 0 to 127 to 500. So I'm taking this value, 0 to 127, and I want to make it go from 0 to 500. Or let's start with a negative 500 to 500.
Does the dot make it a float?
Yeah, the dot casts it to a float. And you see it has all these inlets. I can connect numbers to there and change the scale in real time. While Unreal's rendering, I can continue to do my interface in Max, which gives me a lot of flexibility for altering things. And then it leaves you all the values here, so you can then write them down and move them around. So connect the data from the control N to there. And now let's peek inside the hood of here. And now we'll see. All right. I mean, it's floats, but it's hard. It's because it's insta floats. It's still going to be. It's not that that much. It's fine. Well, I'm really sorry. No. Okay, and so we just want to send this on a channel. So OSC, we've done it before. We're going to send this on position, right? We're going to send this on. Let's make this be our Z. Okay, so we're going to put this on a channel. We're going to send this on. I'm going to use another message, and we're going to put it on. Let's just say Z, and then a value, a variable in max is called $1, and it's going to come out, and then we're going to send it over to my own computer. Just a different software.
So you are using the open sound controller.
Yeah, so this is going to be, we're going to send UDP. Yeah, we're going to send open sound control. So this,
Why /Z?
so actually, so open sound control is like an internet protocol, and it goes on URLs. So if I really wanted to parse out some stuff, I could have like everything that's camera would be / camera, and then position would be on one channel, then rotation on another channel. You can parse things out like that. We're just doing it very simple and just sending it off on this channel of Z, just like a URL, because it is a low latency lossy protocol used for live show control. So I'm going to be sending UDP send. OSC is just a framework for packaging up UDP protocol. And then when I get to the end of this word, it autofill it for me. And it says what's the host. You can't probably see that. What's the host and what's the port? I'm localhost. I'm using my own computer. So localhost. And then the port we're going to designate later, but I know that it's going to be port 8001. And this is it. I now have this value, and it's being sent over to Unreal. Okay? Yeah, I'll go ahead and save it. This is Max crashes all the time, so okay. So we're gonna get the OSC plugin from scratch. So I'm gonna look up just UE4 OSC. It's the first one, and I'm just gonna download it, and I'm gonna create a new project. I'm gonna do it in 413, and there we go. And to compile a plugin, we have to actually do C++ project. We're not going to do any coding. It just has to be able to connect to Xcode on your Mac and Visual Studio on PC. I usually make a project called compiler for each version engine number I have, and I already have one for this one, so this would be just another number. I don't need any starter content. I don't need anything. This is going to be like an empty project, and I'm just going to create it. This might take a few seconds. So I'll go ahead and grab a plugin. Okay, there's 2 folders in here, and this works for both Mac and Windows. This OSC folder is the plugin itself, and then these examples are examples that you can drag into your levels that are just drag and drop. You don't have to do any blueprints. They just say, here's the actor I want to get data from, and here's the actor I want to move around with data. And then you can break it open if you want to see how it works. So this will take 1 second. And by 1 second, I mean 5 minutes. Can I be multitasking? No. All right. Great. So this opens up. Don't care. I'm going to close it right back. And then also the project's going to open up, and I don't care. I'm just going to close it right back. I'm going to find it. If I go over to the launcher, and I see this is the one C, show my folder, and I'm going to create a new folder called plugins. Put OSC in there. And then it's going to ask me if I want to compile it. Or maybe it won't. Hopefully it will. Let's see if that worked. Okay, so we're going to go to this plugins folder. and we'll see if it's down here. Oh, OSC, and it's enabled. All right, so we have OSC enabled, but I want to see what ports it's sending and receiving on. So I'm going to go to my project settings. If I come down here to the bottom, you see there's OSC plugins, and we're receiving from 8000. I know that in Max I did 8001, so I'm going to change it here. And then we're going to receive, we're going to send it from Unreal back to Max in a second.
Yeah, that's that.
Yeah, so the send, I put on different ports. It just makes sense to me, you know. Driving in the same lane seems like it would be conflicting interests. So there we go. So now we're going to do this. Now, I have this plugin compiled. I really don't care about doing anything in this compiler one. It doesn't have all my assets. I was working on something that didn't have C++. But I want to have OSC available for me at any time. So I'm going to, and this is, in Windows it's much easier. Mac, this was, Jed and I had to go look for this. We're going to take this plugin, and we're going to go to the root of my computer, hard drive, users, shared, Unreal Engine, version number, engine, plugins. So this will be this is screen reported, so you guys can find this. You can search for this. I already put it there. I've put OSC in here. It's right there. And now every single project I open up that engine has that plugin. I don't have to do it for each version. I think that you were doing that for the OptiTrack, right? Yeah. So that way you don't have to worry about your plugins. It's available for every project. And sure enough, if I go over here to this 413 project, I probably already have the plugin available as part of the engine. It's not just a project thing at the bottom. It's part of the engine now. You just, when you start a new project, you have to enable it and then restart the editor. It's not on by default. All right. And so we were going to control a camera with this. That's fine. But as we showed a little bit of OSC, and it involves having a blueprint. So we're going to create a special kind of blueprint that we haven't done before called a pawn. A pawn is something that can be controlled. Cameras want to be, we're going to be able to make it a blueprint that can be controlled, but also receive the MIDI via OSC. So I'm just going to create a new blueprint class. It's a pawn, something that can be controlled. BP camera test. And a very simple blueprint. And that I'm just going to add a camera to it. Drag it up to get rid of the scene root, which is just a visual representation of where the blueprint is. And then I'm going to add the OSC component. Over here on the right, you know how we did, we made collisions for overlap and end overlap. This is also an event that's unique to OSC receiver on OSC received. Press the plus button there, voila. This is an event dispatcher, not dispatcher, this is an event sender. This is called OSC received. And you see that it has address and data, and then this top is an execution pin. This is the bangs, this is the thing that's the events that are being sent out. So over in Max, in Maxland, we're sending values on Z. That's it. So that's going to be our channel. So the address equals, I'll zoom in a little bit for you guys. I guess it's as close as it's going to get. /Z. That's the channel it's coming from. And then from the data, if I hover over there, it says it's a structure. It's a complicated thing. It could be bool, string, int, float. We want to specifically get the float numbers that we're getting from there. So for this plugin, we're going to pop a float, taking it off the top. Every time we take off data, we're popping off a float, popping up an int, and you can print string to help distinguish all this stuff for you. In blueprints, an if statement is called a branch, which we've used those before. And that's a conditional. And if the condition is that data is on channel Z, we are going to use this value to do what? Well, we're going to have a camera, and we're going to set the world position, world location, excuse me. And that's going to be the driving force right there, that execution pin. And this is a float, and our position is a vector that's 3 floats. We're going to split it open by right-clicking and splitting it and sending it on Z. Okay? There it is, just a few objects, and let's see if it works. I'm going to drag this off into the world, and this time I might want to, I don't know, put something in there so you can see if it works. So I'll get some geometry. Spiral stairs sounds awesome, right? There we go. We rotate around so we can see the stairs. There we go. That would be cool. All right. And now, what this has that like an actor, blueprint actor, a standard one we've been using before, it doesn't have this auto possess. In the same way we had it tells other cameras which person it was. We can allocate different OSC to be different players for different screens by making it a camera pawn. The only reason I did that was for this checkbox right here. It is going to take over the screen. So just do a quick save. Camera test. Hit play. Let's see why it doesn't work. Let's put this above ground. And input. Oh. I think it's this one, input, actually. Let's see. Shunk, shunk. Let's enable it. Let's take a look at what we're doing. And then what I'll do is while I'm playing, I'm going to see if it's firing off. So it's not receiving anything. Let's check our ports. All right. So it's on channel Z. On channel Z. We can print out. All right. So we're definitely sending it on Z. Close that up. Yeah. Excuse me. Not 8001. So I'm sending 8001. Let's see what we're receiving on. We're going to check the ports. And through the project settings. And it's receiving from 8000. So that's why we have to, know what we're doing.
You don't know what you're doing?
I'm live coding. I was like, I did a whole bunch of examples all day long, and I'm like, hey, let's do the one I never did before. Okay. Yeah. Yeah. Either one, and I switched around. Yes, Mahi. You can only receive from one port. Yeah, but you can send to that port from many different things. Yeah. Yeah. So let's see if this magically works. There we go. So now, I had faith in me. All right, so so like this is so much easier to do small granular control over things and really like dial in things. This could be, emission levels. This could be positioning. This could be scaling. If you're in VR, doing this kind of stuff makes it really intuitive to really put it where it needs to be. And now, one thing we haven't done yet in class, and I can show you guys just for fun sometime, is that Unreal does have the option to do VR editing of any of your scenes inside the Vive. And that's just like a little button press. We can't do it on this computer, and I'm probably going to scare Yao. Okay, I was kind of hoping to scare you. So if I wanted to do this in edit the scene, this is one way. We can also do it with the Vive controllers. We can go into the editor settings, editor preferences, and I think it's like experimental at the very bottom. It says enable VR editing. I click that button. Watch the top bar. Click that button. Boom. We now have a VR button. So now you can watch the thing in VR, but you can also then use, and it has contextual clues. It'll tell you how to use the controllers as you hold them up, just like Tilt Brush tells you how to use the controllers. And you can get into your world, and you can start scaling things and rotating things around and applying materials. And it's actually, once you get used to it, it's actually kind of it's a different tool. I'm not saying it's better or worse, but creating VR in VR is the main use of VR, or is the best use of VR.
For like blueprints, it doesn't, right?
No, blueprints. What it does is it'll stop, and then you come down and do your stuff, and then when you come back into your world, you put it back on. It's definitely you hop up and down.
Making assets is kind of hard too, but what is cool is that you can have all of your assets and just dump them, and then with the Unreal Editor, you just place them around and scale them accordingly. That is pretty cool.
It's super fun. So what we're going to do now is just go the other way. You know, I think that this is going to help some groups where they're getting the data from. Now, obviously, we get the data straight from Motive, but I'm just kind of this is kind of my workflow that I like to do. We're getting the data from Unreal, and then we're going to drive sound in Max. This might work for some particular group that might be doing spatialized sound in Max. So this level is great. I love it. I'm just going to kind of add to it once I stop it. There we go. So there's one thing. Actually, I'm gonna close this real quick. And there's one thing I didn't show you was that not only did I have the plugin, but it also comes with blueprint examples that are very easy to use. So I'm gonna go find that project that I was just using, which I do believe was week 9. Weeks are irrelevant now. Show in folder. And then inside my content folder, I'm going to put this examples. All right, I'm going to restart. We're going to find that. Yes, import. Great, thank you. Let's find that thing I just made. Nope. We're going to filter content, find my levels. Oh, I already got so many. Camera test. All right, so I'm going to add an object to this world. I'm going to just make it a cube. That's just sphere, sphere mode. Great, so this is now an actor in this world. I'm going to go to my content folder, go filter, and I'm going to look at those examples. So the blueprint examples, I'll just read them out. One of them is a location sender. I'm just going to put this location sender out into the world. Okay, it's there. And on the details panel over here, it says what address. It's already given me the address for position. And it says what is the source, what is the object. There's a little trick here. I'm going to click this little lock right here at the top so it doesn't go away when I select another item. I've now selected that other item. I'm going to bring it in here. I have the sphere. I'm sending the location of the sphere over OSC. All right. I'm going to unlock it again so I can now check the sphere, change it to movable, and then in my level blueprint, I'm going to use this item called the timeline. And just with nothing selected, with no context, it's the very last item, timeline. Okay, this is just a simple way of doing some keyframed moves. There's a float track. I'm going to add a track to do floats. And then I'm going to make a keyframe, time 0, value 0. Add another keyframe. The duration of this is 5 seconds long, so I'm going to add another keyframe, and I'm going to make that at 2.5, and we'll do 500. And then I'm going to make another keyframe, and we're going to make that one at 5 seconds, and make it back down to 0. There's these 2 little buttons here to help put things zoom in to the right size. Oh, did I not put one at the very beginning? Yeah, I did. Broken. Anyway, so here's our keyframes over the 5 seconds, and then I'm just going to use this little click box for autoplay and loop. So this happen over and over again, and I don't have to worry about executing it. It's just gonna happen. Okay. Go back over to the event graph, and what am I moving around? I'm going to move around. Go back to context sensitive. I'm going to bring in that sphere, and all I want to do is set world location for that actor. It's going to update it constantly as it goes through the timeline. It's going to keep on updating it, and it has that float track. I'm just going to move it up and down. Split this again, and just go up and down Z. All right. So ideally, we should be able to see this in Max. The one thing, well, actually, I'll make the mistake first, and then we'll learn from the mistake, right? So this ball
Whoa.
is moving up and down. Okay. So that worked. That's great. That's relief. But if I go over to Max, if I go to any other application, any VJ thing I might be doing, oh, did Max crash at some point? Oh, that's why I didn't do. Anyway, now Unreal is what's called a background process. It's not the frontmost application. And you've noticed it's gotten choppy, right? It's conserving energy. It knows it's a resource hog and it's conserving energy. What we need to do is stop this, because the data we'd be getting from it would be very choppy. Go to the preferences. Go to the preferences again. Oh, there we go. Editor preferences underneath experimental. It's nice. Now it's probably miscellaneous. Miscellaneous. Use less CPU in background. We got to do this. We're doing live show control. So there we go. Now I'll run smooth as butter. Delicious, delicious butter. When it's in the background. So let's peek into the data that's being sent in. This one was UDP send. We're going to do UDP receive. Makes sense. So it's a new object. I can drag this, or I can type in an N for new. UDP receive. I don't have to designate an IP. I just need to tell what port. So I think I changed it back to 8001. We'll find out in a second. Yeah, so let's go back and change the port for the sending. Come on, guy. Actually, that was in the project settings. OSC. And I'm receiving there, but I need to send on 8001 localhost. Cool. All right. All right, so we're getting position of that object. This can be, we can get position and rotation from all these things. So it says position right here. We'll just scoot in a little bit. It says position. We could be getting a whole lot of values, right? We could be getting all these channels, all this kind of stuff. We want to start routing our data. And it's literally called route. Just gonna edit this. So, unedit. So typing in new for new object and type in route. And I'm going to route this channel position. This route object could have like just hundreds and hundreds of things depending on how many channels you use. So we're going to be funneling out position. If I highlight over this outlet, it says outputs if input matches position. And this is just a dump of everything else. Let's take a peek at what comes out now. I got to connect it first. Now we just have 3 numbers. But I don't care about these 2 zeros. They're not giving me anything fun. So there's a whole bunch of different ways of doing this. I'm just going to, let's say they were giving me information, I want to separate them out. I'm going to unpack them. And I'm just going to let it know that I know they're all floats. I'm going to pack these 3 floats. You see this is now updated to have 3 different items there. Let's take a peek at the last one. We're just getting 1 number. So this is super fun. Now I'm going to go to, we're going to turn this into a sound. Everyone loves, a creative coding theremin. So we're gonna do a digital to analog conversion. So this is going to be, there's an object called easy DAC. That might look like a familiar icon of a speaker. All right. I'm going to create a little volume by creating a multiplier. Everything in audio at max has a tilde, so it's going to be a multiplication tilde. And all the wires that have to do with audio are these cool like tweed things. So it's a stereo channel. And I want to take this signal and I'm going to make it drive a sawtooth wave. Type F for float to give it a value. Plug them in. Plug them in. Hope that it's not too loud. Lock it. Turn it on. Let's see. I'm using 0. Ah, see, there you go. Thank God. I think I went up to like a volume of like 500, which is like would kill us all. Yeah, it's no. This is like a few, like a full few. I'm just gonna click on the thing and I say nope. Go over here instead. This one goes to its infinite. No. Do 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 do. Oh, am I muted? Let's go back down to 0. Do do do. Do do do. Do do do. Do do do. Oh, because I'm also a jerk. This is the multiplier. Okay. Now let's spot check it. Do do do. So there is volume. I'm probably using the wrong device. Let's go to my audio settings or preferences. There's audio. Oh. Let's just go for my built-in internal speakers. And then in Max I also do that. Built-in output, great. What can I do to prove to you guys this actually works? I changed the output to internal speakers. And we just restart Max really quick. Jed, this worked, right? Totally worked. Let's restart Max real quick. So we're going to do the internal speakers. What was that? Mute.
Mute.
All right. Okay.
What?
Okay. Who's having fun? And that volume is at point like 4, so I'm glad we didn't do it when it was at 500. So we've now, created the theremin that we've always wanted. So I don't know if anyone's ever gonna get sick of that sound. No, we'll just keep on going. We'll just keep on going. We just move this to the back. No. Okay, so I just want to show you one more camera thing, and then we'll be done for the day with this stuff. Oh, yeah, it's still sending out the sound. One more camera thing that's kind of fun, and then we'll move on and like break into groups and just see if you guys have any questions for us that we can help you with the unit assignments. So I think I was showing Lisa this, but we want to create actually how do you do mirrors? How do you do like security cameras, that kind of stuff? We want to put a camera in our scene that actually renders to a texture in our scene. So I'm just going to show you the last camera thing that I haven't included with everything, and it's called a scene capture 2D. So this is going to be a camera that's going to render to a material that we can put onto anything in our world. Okay. So
Patrick, so
Yep.
this one will, can this one do the offline rendering to doing some trade, high-end trade or actually component to the game?
no, it does the real time stuff, but the spherical output for Unreal is a kind of a hacky blueprint that's made out of these. You see this other object that's called a cube. This one gets like the 6 different angles and stuff like that. It's definitely something to play around with. It's extremely CPU intensive. This is all on the CPU. So we want to be able to put this on a texture. I'm going to do this kind of like the easiest way possible, which is it has a texture target. Instead of like creating something from scratch, I'm just going to let it create things for me. Make me a render target. There, it's creating a texture for me. I'm just going to hit save. So you might not be able to see it there, but if I hit the spotlight, there it is. Let's just hit play, and it'll be updated. Hit play, and then I hit escape. Well, it's not saving there, but you guys believe me. What we need to do is create a material out of that, and then if we're doing a video texture, usually video doesn't accept light, so it's unlit, and usually it emits light, right? Like an LED screen or whatever, or a TV or anything. So there we go. You can see that it has that texture in there, and then in front of our camera, this is going to be kind of wonky. Let's see how this works. Yes, but it's emissive with no glow. Yeah. So there we go. And we probably need to have, for our benefit, let's see if we have anything fun. We probably need to have some like things in there to make sure that everything's moving right. All right, so let's just put in some steam, some fire, and some sparks in front of the camera so that we can see it.
So you get the effect of a mirror though when you put the camera behind, like right in front of the surface. So
Yeah, if you're gonna do a mirror, I'm not really making a mirror. I'm just showing the thing.
okay.
Yeah, and then we can also take off and just put this on the floor. There we go.
You know,
Yeah, just whatever.
oh man, did you make like a
That's what I kind of want to show you. So now this is a camera within our scene that's sending out to other things. So this has a lot of possibilities, and this is kind of how you do portals, right? So once you cross threshold, then you port instead of looking through the scene capture element. And there's reflectance objects and reflectance properties materials, but this is actually how you do mirrors and stuff like that. So that's all I was going to show you. We don't have that much more time, so I'm just going to do one more demo from the phone. No, we'll stop. That's it. I'll do phone if somebody